This lecture is intended to get us started on our unit on evolution. Before we begin to understand evolution and how so many different species came to be, we have to have a basic understanding of how long our planet has been around. Often when we think of change, we think of things that happen quickly, maybe within or throughout the day, maybe within a week or a month, or even the changes that occur during our lifetime, like the new iPhones or the new technology, whatever it might be. But when we're discussing geologic time, or the time that our planet has been around, we call that geo means Earth, so geologic time is the span of our planet's history. When we're talking about geologic time, it's important to understand that change does not occur overnight. The time periods that we're dealing with here are very big, bigger than a generation, bigger than a century, and occasionally even bigger than a millennia. Numbers this big, numbers in the billions, are hard to comprehend. So I found a few video examples for us to go through. As you're watching the videos, you don't have to write anything down, but be prepared for some review questions afterwards. Our first video is a TED video.
How old is the Earth? Well, by counting the number of isotopes in a sample of rock that's undergone radioactive decay, geologists have estimated the Earth's birthday, when it first formed from a solar nebula, to be 4.6 billion years ago. But just how long is that really? Here are some analogies that might help you understand. For example, let's imagine the entire history of Earth until the present day as a single calendar year. On January 1st, the Earth begins to form. By March 3rd, there's the first evidence of single-celled bacteria. Life remains amazingly unicellular until November 11th, when the first multicellular organisms, known as the Ediacaran fauna, come along. Shortly thereafter, on November 16th at 6:08 p.m., is the Cambrian explosion of life, a major milestone when all of the modern phyla started to appear. On December 10th at 1:26 p.m., the dinosaurs first evolve, but are wiped out by an asteroid just 2 weeks later. On December 31st, the mighty Roman Empire rises and falls in just under 4 seconds, and Columbus sets sail for what he thinks is India at 3 seconds to midnight. If you tried to write the history of the Earth using just 1 page per year, your book would be 145 miles thick, more than half the distance to the International Space Station. The story of the 3.2-million-year-old Australopithecine fossil known as Lucy would be found on the 144th mile, just over 500 feet from the end of the book. The United States of America's Declaration of Independence would be signed in the last half-inch. Or if we compare geologic time to a woman stretching her arms to a span of 6 feet, the simple act of filing her nails would wipe away all of recorded human history. Finally, let's imagine the history of the Earth as your life from the moment you're born to your first day of high school. Your first word, first time sitting up, and first time walking would all take place while life on Earth was comprised of single-celled organisms. In fact, the first multicellular organism wouldn't evolve until you were 12 years old and starting 7th grade, right around the time your science teacher is telling the class how fossils are formed. The dinosaurs don't appear until 3 months into 8th grade, and are soon wiped out right around spring break. 3 days before 9th grade begins, when you realize summer is over and you need new school supplies, Lucy, the Australopithecine, is walking around Africa. As you finish breakfast and head outside to catch your bus 44 minutes before school, the Neanderthals are going extinct throughout Europe. The most recent glacial period ends as your bus drops you off 16 minutes before class. Columbus sets sail 50 seconds before class as you're still trying to find the right classroom. The Declaration of Independence is signed 28 seconds later as you look for an empty seat, and you are born 1.3 seconds before the bell rings. So you see, the Earth is extremely, unbelievably old compared to us humans, with the fossil record hiding incredible stories to tell us about the past, and possibly the future as well. But in the short time we've been here, we've learned so much, and will surely learn more over the next decades and centuries, mere moments in geological time.
Alright, hopefully you were able to make some connections with that video and get a better understanding of just how long our planet has been around and how much time it takes for things to happen. There's a few review questions for us to go over. As we go over them, just think about them. You don't have to write them down. Geologically speaking, with reference to the entire history of the Earth, the dinosaurs went extinct when? The dinosaurs went extinct in the most recent 2% of the history of the Earth, meaning that for billions of years, the Earth was populated by either no life at all or by simple single-celled organisms, which later advanced into the multicellular organisms that we see today. How old is our planet? Our planet is 4.6 billion years old, so 4,600,000,000 years old. 100,000 years in terms of geologic history would be just a drop in the bucket. When we're talking about geologic time and evolution and changes in Earth's history, it's important to realize that the time scale we're referring to is of billions and millions and billions of years. All right. A more visual example for us to look at would be Earth in the palm of our hand. So if you outstretch your right arm, we can compare the length of our arm to the history of all living things on Earth. Remember, our planet is about 4.6 billion years old. It took about 1 billion years for any life at all to form. That life was simple prokaryotic cells, and it took about another billion years for eukaryotic celled organisms to form. So pro means before. Prokaryotic cells came before eukaryotic cells. So actually back here, there's about another 2 billion years. Now, life on Earth was pretty darn simple until we get to about the middle of our palm. Then came an event called the Cambrian explosion. During the Cambrian explosion, we saw a lot of diversification or changing in the living organisms here on Earth. Later on came the dinosaurs, here towards our fingertips. Then came humans. So, humans occupy the fingertip of Earth's history. Recall in the TED video, it said that if we file our fingernails, we would wipe out all of human history. So if we go back to our PowerPoint, I'd like you to pause on this scene for a few minutes and reflect on the image that you just saw. If you look at the span of living things, a lot has happened from the middle of our palm to the tips of our fingers. What do you think could cause so many changes to happen so quickly? And recall that quickly here is considered millions and millions of years. So what could cause so many changes to happen in that little time? Please pause the video and jot down a few notes in your notebook for your reflection. A third example for us is to compare life on Earth to one day.
Brag about what's in new Life and Fit yogurt, but we'd rather talk about what's not in it, like no artificial.
Life. With an estimated 3.8 billion years of existence and evolution on Earth, it's an odd thing indeed. So how did we get here? And what would the Earth's 4.5 billion year timeline look like compressed into a normal day of 24 hours? The story begins early in the morning, around 4 a.m., with the rise of the first simple, single-celled organisms. However, these organisms are destined to spend quite some time alone. At 1 p.m., a simple cell engulfs another, creating a symbiotic relationship and the first eukaryotic cells, or cells with internal organs. At 6:30 p.m., these cells begin to form colonies, and thus the first multicellular life develops. But it isn't until 8:30 p.m. that sea plants appear, and 20 minutes later we suddenly see animal life erupt in an explosion of inventiveness. Jellyfish, the first true vertebrates, trilobites. Incredible diversification begins to take place, and just before 10 p.m., plants begin to appear on land, followed by land mammals. By 1024, the Earth is covered in carboniferous forests, and the first winged insects appear. Many reptiles dominate the land with less than an hour left, but a mass extinction event allows dinosaurs to storm the scene and remain until 11:41 p.m., when they too suddenly vanish. And so begins the age of mammals. In the last few minutes, apes split from the old world monkeys, and with only 1 minute and 17 seconds left before midnight, humans emerge. All of the recorded human history fits within a few seconds, an individual life lasting barely an instant. All a culmination of 3.8 billion years of life. This ASAP.
As we've seen from our three examples, our planet has been around for a very long time, and we occupy only a little sliver of that history. As humans, though, we have quite a bit of power over our planet. So my last reflection question for you, and once you have a chance to read it, please pause the video and reflect in your notebook for a bit. The Earth has an incredibly long history. How does understanding that history and geologic time impact your understanding of humans' unique responsibility and place on Earth? Do you think it is important for us to understand geologic time? Please pause the video and write down at least a 3 to 5 sentence reflection on this question. I will be checking your notebooks for the 2 reflection questions, and we'll review the content that you watched in this lecture next class.